So this starts out with a bit of a reminder that when we are calculating quantities in chemistry, we always calculate via the mole. So we need to convert masses of quantities given, reactants that were given in the question, say, to moles. Then using the mole ratio of the balanced chemical equation, we can work out masses of anything else that's involved in the reaction. So our example is 20 grams of calcium carbonate plus excess hydrochloric acid. And we're not going to be able to do any calculations without the balanced chemical equation. So where this has been given to us. Mind you, this book is so riddled with errors that sometimes it's a good idea to check it. But this is a very familiar reaction. What do we call this reaction?
Combustion.
Acid plus carbonate. Just an acid plus a carbonate reaction. Yeah. Which always gives us then carbon dioxide and water. So the mass that was given in the question is the mass of this reactant, and it tells us this is in excess, so we don't need to worry about that in terms of our calculation. So this is little m, and we need to find the moles. So the way to find the moles is by using that relationship there, where the sample mass divided by the molar mass of the substance will give us the number of moles. So my moles of calcium carbonate will equal 20 divided by the molar mass of calcium carbonate. So what's the atomic mass of calcium?
40.08.
40.08. 12.01 for carbon and 3 times 16 for the oxygen. And I'm just going to use the book here. And look, they've done a separate calculation for M, capital M, molar mass. But if you want to do it this way, that's fine. I just don't want you plucking numbers out of thin air. So showing where they've come from, okay, is important. So we'll find this is 0.200 mole. So that's how much we have. If I have 0.200 mole of calcium carbonate, how much calcium chloride will I produce?
The same amount.
The same amount, because they are in a 1-to-1 ratio within the balanced chemical equation. What about carbon dioxide? The same. Same. And the water is the same. Now, even though it was in excess, how much of the hydrochloric acid did we actually use? 0.4. Okay, because what we've had to do to go from here to here then is multiply by the coefficient in front of the hydrochloric acid. So we now know, and this is how I would suggest you write it in your working, moles of calcium carbonate is equal to the moles of carbon dioxide. Therefore, moles of carbon dioxide, 0.200 mole. Okay, again, this is my justification. I'm saying I've looked at the balanced equation and I know my mole ratio is 1-to-1. So that's why I've just decided that I've got 0.2 moles of calcium carbonate. So I want to get back to my mass of carbon dioxide. And my mass is equal then to my moles multiplied by my molar mass. If I rearrange this equation so that the sample mass is now the subject, I'll end up with this arrangement. And so the mass of carbon dioxide will equal 0.200, and it's going to be multiplied by the molecular mass of carbon dioxide, which I've just put in brackets so that we don't get our order of operations mixed up. And that gives us a value then of 8.80 grams. And that was 3 sig figs, and this was 3 sig figs as well, to match up with the 3 sig figs given in the question. We're also asked to determine the mass of hydrochloric acid required. We've already found the moles up here, and so my mass of hydrochloric acid will equal the moles multiplied by the molar mass. So that's 1.008 plus 35.45. Which is going to give me 14.6 grams. And again, that was to 3 sig figs. Okay, does anybody have any questions about that? Hopefully you can see that there is value of writing those brackets of what you're working on, just to make your working clear. It certainly helps me when I'm reading your work to be able to follow your line of thinking. So you can have some time now, probably, let's say, 20 minutes to work on the questions on page 25, and then we're going to go on to limiting reactants.
When you're actually working out, is it necessary to put the formula you're going to use, like the marks?
I would suggest that the formulas are your justification.
So we do need the line.
So I expect to see formulas, yes. Otherwise, again, that could be just being blocked out of it.